All right, you should have your essential question written on your paper saying how can you graph or write quadratics in standard form. Today's standard form, tomorrow's vertex form. We're moving on from just solving them. Now we're going to actually graph them. Okay? What were we finding when we were solving them all those times? X-intercepts, right? Now there's more than just x-intercepts when it comes to a quadratic, okay? You have done this before where we've given you the quadratic and asked you for different pieces of it, right? So looking at this, you can tell me, does this open up or down? This parabola is opening up.
How do you know that?
But it's smiling at you. It's going up. Look at the arrows. They're going up.
When it's smiling, it's going up.
Yeah. Yep. Axis of symmetry. So that's like a line that's cutting this guy in half. Where is that axis of symmetry? Okay, there's x of 1 and there's a y of 1. Which one is this? X. Go, we're cutting through the x-axis, so this is x is equal to 1. Okay, that's how we write a line. When we do a line, it has to be, there's an equals to, okay? The vertex is this lovely guy right here. What is the vertex going to be? Good. Yep, 1, -1. Notice the x for my axis of symmetry is the same x for my vertex. That will happen every time because your vertex is always on the axis of symmetry. Okay, so that was the line. This is how you write a point. All right, where are the x-intercepts here? All right, I see one happening at 2, and I see it happening at 0. Am I going to write 2 and 0? No, how do I write the points? Well, I can't do equals because that would be a line. What's just the point?
0, 0,
2, 0. Good. That's how we write the point of our intercepts. And then last but not least, where is the the y-intercept? Right there. Where is right there? It is at 0, 0. Yes. Good. Yeah, technically that is the origin. These two things, you're right. That is the origin. Good. So do we remember? We're able to look at a graph and pick out certain pieces. Okay. We're still going to use that today, but instead, now we're going to actually create the equation out of it. Okay. So they gave it to you here. They told you y was equal to x squared minus 2x. If they didn't give me that, I could use all of that information to write it. Right? That's what we're going to do today. So the standard form of quadratic, okay, it is ax squared plus bx plus c. We're saying equals f of x. That means it's the function. We're graphing it now. But that's the same thing as saying equals to what? F of x is the same thing as saying y. Same thing. Okay? So these are technically the same thing. We use it when it's equal to y when we're finding like a specific point. Okay, but f of x just represents all the points in the whole function. All right, so again, we're going to use this stuff. They're going to give me the equation and ask us to graph it, and then they're going to give us the graph and ask us to write the equation. So we're going to be able to do both ways today. Here we go. First one, we have 3x squared plus 2x minus 1, right? Steps for graphing. So they've given us an equation. They want us to graph it, okay? So on the left-hand side, the first thing we're going to do is decide if it's opening up or down, okay? And we figure that out by looking at our a value. So remind me, where does a occur in the equation? Yeah, it's this guy right here. That whole piece, right? So since my a value is 3, is it going to open up or down? It's going to open up because 3 was positive. Okay, so we're going to open up. So it's going to look something like that. It's going to open up. I know the little squares you have don't have a lot of room. The back is blank. So if you want to wait to do your graph until the end, that might be a good idea. because we're going to be fitting a lot on here. Okay? All right, step 2, we're going to find the axis of symmetry. So that is negative b over 2a. Does that kind of look familiar? Yeah. A little bit? Where did that happen before, maybe? Yeah, quadratic formula. There's the discriminant, and then there's this piece, negative b over 2a. Right? So the discriminant tells you how many solutions and what kind. The other half is going to give us our axis of symmetry. Altogether, it gives you our x-intercepts. Look at that. Such a wonderful thing. So negative b over 2a. What is b in this equation? It is 2. Good. What is a in this equation? We already figured that out. It was 3. So this becomes negative 2 over 6, which simplifies to negative 1/3. That is our axis of symmetry, which is that line that's cutting down the middle. Now we said what else was always on the axis of symmetry? Say it. Yes, our vertex is always on here. We've just found what piece of that vertex? The x or the y? Yeah, we just got the x value. We don't know the y value. Okay? We don't know y right now. In order to find y, though, we are going to plug it in. So we're going to take y equals 3x squared plus 2x minus 1. And we're going to change all those x's to what we have. We know it's negative 1/3. And I should probably put a 3 right there. Here we go. 3 times negative 1/3 squared plus 2 times negative 1/3 minus 1. All right, let's simplify. We need to do exponents first. Negative 1/3 squared. Remember, that's the same thing as saying negative 1/3 times negative 1/3, which gives me what? 1 over 9. Okay. That becomes 3 times 1 over 9. All right, now let's multiply. 3 times 1/9 becomes what? That's like saying 3 over 9, yeah, which is 1/3. Over here, 2 times 1/3, that's like saying 2 over 1 times 1/3, which is going to give me 2/3. And then we have minus 1 over here. Now, if I write it like this, yes. It is, thank you, yes. Was that what you were going to say? Okay, yep, thank you. All right, how come I rewrote 1 to be 3 over 3? What was the point of that? Yeah, when I add and subtract the fractions, my denominators have to match. Okay, so I changed 1 to just be 3 over 3. It's still the same thing, I just wrote it in a different format. Okay, so now we can just go straight across. So 1 minus 2, what is that, negative 1? And then negative 1 minus 3, negative 4/3, that is our y. I know. I mean, we do a lot today. I'm letting you know. We do a lot. No, there are 2 more steps. I know. It's a lot. We got 2 more things to do. Well, we've technically it's only 1 more, because we've been graphing. Step 5 says technically graph it, so we only have to find 1 more thing. What is that 1 more thing, do you think? Our x-intercepts. Yep. And how are we going to find x-intercepts, guys? You've been doing it for weeks. Factoring. That's why we've been doing it. Yes. Factor. Solve. Told you, it's not going away. Not going away. Okay? So, step 4 is going to be to solve for your x-intercepts. So people are still writing this down, so I'm giving them a second. But step 4 is to solve for your x-intercepts. Does anybody still need this slide?
The top part. I just do the little graph.
I'm gonna do the graph again on the next piece. Yeah, so you're good. And I'm gonna make it like pretty and stuff too. Look at that. So step 4 is solve for those roots. So we're gonna set it equal to 0 and solve. So we have 3x squared plus 2x minus 1 equals 0. All right, how are we going to do this? Sleeping slide. All right, so we get x squared plus 2x. What is that? Minus 3. What's my next step in slip and slide?
You gotta do the thingy, and then you gotta x minus 2.
Almost. They have to multiply to give you 3.
Oh,
And add to give me 2.
X plus 3x minus 1. Gummit.
Plus 3 minus 1. I knew what you meant.
I'm such a tryhard. Yeah, they did 3.
So does that mean my answer is negative 3 and positive 1?
I gotta slide it down.
Good, we gotta bring my 3 back out. This means we have x plus 1 and x minus 1/3. I can, but do I really have to? Because we're solving, right? Is it though? Because now I can just say x is equal to negative 1 and 1/3. So you could say 3x minus 1. Then you would add 1 and divide by 3, and we would get the same thing. So you would not be wrong. It would still work out. And then, yes, our final step is to graph it all. So we've kind of slowly been doing that. So here we go. Negative 1, 1/3, that's like 0.3. That's like right here. What was our vertex? Negative 1/3 and negative 4/3. So about right here somewhere. That's true for our axis of symmetry. Something like that. Okay, you've probably been sketching it. Okay, so we started off saying it was going to open up, right? Then you do your axis of symmetry. You're going to label your vertex just like we did. What was it? Negative 1/3, negative 4/3. Then we have a y-intercept of an x-intercept of negative 1, 0. And another x-intercept of 1/3, 0. That's sketching your graph. That's the same. I know your paper doesn't have the graph paper on it, so yours will look like this. Just make sure your stuff is labeled, okay? Make sure your stuff is labeled. So you don't have to actually draw a graph, an XY axis, and then put it on there. And just draw the parabola and label the pieces. I'll be better about giving you actual graphs in the future. It took up space. Good? Yes. What is it? Explain the graph? What part of the graph?
It's like
I labeled my vertex and my x-intercepts. The parabola's opening up. Did we get that part? Okay. Do you know where the vertex came from? We did that on the slide before. Okay, so the vertex is the point that's on the axis of symmetry. And then your zeros are going to be on the sides. That's where it's crossing the x-axis. This is a sketch. Like that's an x-axis. Yes. and then like here's your y, like that. No, it's okay. Does that kind of help?
Yes,
Okay.
I was like,
All right, ready to do another one? Here it comes. Okay, you're fine. Here we go. 2x squared minus 4x minus 1. Okay, you think it's going to go up. And he said it was because 2 was positive. Do you look at the right spot? Yes. What does what mean? Gx. Oh, it's just another way to write the function because we already used f of x. So technically you can't say f of x again because they're not the same equation. It's just showing you it's a new equation. Yeah, it's function. It's just showing you it's a new function. So we're not using the one from before. It's a new problem. Yeah. Yep. Yep. It's just showing you it's a new function. Good question. All right. We know this guy is going to open up. How about our axis of symmetry?
So you would put 4 over 2. The 4 is
Right. So negative b, right, over 2a. My b already is negative 4, so that's where he's getting positive 4 from. Our a is 2. 2 times 2 is 4. So what is our axis of symmetry? Uno. Yep. So meaning we have a line going down like this, right? Positive 1. All right. What does that also give me?
Your x here. So you can plug it in.
I'm gonna plug it in because it gives me the x of our vertex. So to find the y, because this function is also equal to y, we plug it in. So we're gonna say y is equal to 2, 1 squared minus 4 times 1 minus 1, like that. So exponents first. This is 2 times 1 minus 4 times 1 minus 1. Here we go. So now we have 2 minus 4 minus 1. What does that give me? Negative 3. So that means my vertex is 1, negative 3.
I didn't do my PIMDAX stuff.
Gotta do the PIMDAX. Alright, what's the only thing left to find? Our x-intercepts. Yep. Good. Do you want to need any of that before I push the button? What's up?
No.
You can't. Someone's saying we can't do slip and slide.
I can't. I tried it. I couldn't do that. That's not possible.
It isn't. Ugh.
Shoot. What do we do?
But what if I also told you don't have to do the quadratic formula? You could, but you don't have to. Yes, we could complete the square. So we're going to kind of like put 2 together. So listen, in our usual slip and slide, we would slip, we would factor, we would slide, right? So you were doing another method in between. This time we can slip, then we can complete the square, and then we can slide, and it still works out. Or you can do quadratic formula. Whichever way you choose is going to work.
So you can add 1 that side.
We're not going to add 1, so it's after the slip. So we still slip 2 over.
Oh, okay.
And then here, we move that like this.
Yeah, and then it would be so that would be
What goes in our blank?
4.
Mm-hmm.
There's 4.
So that becomes x. Good. Minus 2. Yep.
And you square it.
Square root it. I'm going to kind of go down here. So now we have, no, I want to go down here. Now we have x minus 2 is positive and negative square root of 6.
And just add the 2.
And we're going to add the 2.
That's interesting.
And now we slide the original 2 back out. Okay. Now what is nice about this is that this is already simplified. Okay. It looks like you could take the 2's and divide them. Don't do it. This one is already in simplified form because I'm going to show you. That was an ugly little.
This is kind of like a plan B.
Okay. There we go. If you did the quadratic formula, okay, quadratic formula, you would end up, after you simplify everything, you would get 4 plus or minus 2 root 6 over 4. Okay, so from here, you would do what? Divide all of them by 2, right? That's how it turns into this. And you wouldn't simplify anymore. Okay, so doing our slip and slide with the with the complete the square in between, we get the most simplified answer. We don't have to simplify anymore. Okay, quadratic formula, we would end up with this guy and then simplify one more step. Okay, so whichever way you go about it, this is still our answer. Now, can I graph 2 plus or minus square root 6 over 2? Not yet. We got to convert this into their decimals. Okay, this is when the calculators are going to come into play. All right, if you have a graphing calculator, you're going to do, or scientific, just not the ones in my room. If you have the ones in my room, wait a second. Everybody else, you will do 2 plus square root 6, push enter, and then divide by 2. Mm-hmm. 2 plus the square root of 6, push enter, and then divide by 2. You should get 2.2 something, okay? Okay. Now, if you have the calculator from my pouches, you have to just do it in a different order. You have to do square root of 6 first. So my calculators use square root of 6 first. Type it in. Make sure you know how to use these.
Oh, shoot.
Yeah. Do square root of 6 first.
How do you do that?
You're gonna push 6.
6?
And then.
Oh, the square root. Wait, it said 36.
Okay. Now add 2. Do plus 2. And now divide 2. And you should get 2.2 something.
I got 36.
And then add 2. And then divide 2. And then negative 0.2. Yep. So their decimal forms were 2.2 and negative 0.2. Those were their decimal forms. Okay? Listen, all the calculators are different, so you need to make sure you know how to use the one you will be using on future assessments. Okay? So make sure you know how to use your calculator. They are all different. Okay? I can't. Okay, so our axis of symmetry was at 1. Our vertex was 1, negative 3, right? And then our x-intercepts were 2.2 and negative 0.2, barely right there. And it looks something like this. I know. Crazy. You have this on your paper, right? So, put in here, what is this? Negative 0.20. And this one right here is going to be 2.20. Mm-hmm. So if I give you the actual graph, you don't have to label your points because you have to actually graph them, right? If there's no graph there to put it on and you're just sketching it freehand, that's when you have to label your points so I know you know where the stuff goes. Okay? Alright? So I think the hardest part with these is just converting our radicals to decimals. Okay? The other steps weren't too bad. Alright? Anything else you have for me? Okay, because now we're going to go opposite. Yes. Now I'm going to give you the graph and ask you to write the equation. So, hold on. Don't write any of this just yet. Okay? This is like our warm-up, so I don't want you to use up the little space you have. Just remembering, we know how to find these pieces. What is the axis of symmetry looking at this guy? X, Y, Z. What is the line? I know it's -1. Is it X or Y? X equals. Remember, when we do that, it's a line. We have to have it as equals. Because it's cutting through the x-axis. All the points on that line are going to have an x of -1. I mean, it can, but it's not right now. Then x equals 0. All the x's on the y-axis are 0. All the x's on this line are -1. Alright, so now where's my vertex? This guy up here, our maximum point. -1, 9. Alright, we have 2 intercepts. What's this one right here?
-4 and
How do I write it though?
0.
-4, 0. And what's this one?
+2, 0.
Alright, and then what is our y-intercept? Y-intercept is right here, guys. What y is that? It is 8. And I write it as 0, 8. Okay? So, hold on. I told you not to write it down because you're going to use up space that you need. We already know how to do this. This was in our warm-up. Okay? You know how to find these pieces. Is what I'm trying to remind you. You know how to find them. We have to use them in the steps it takes to go from graph to equation. Okay? So on the left-hand side, the steps. Your very first step is going to be to identify the y-intercept. Okay? You know how to do that. We just did it. We looked at the graph. What was our y-intercept? What was the y-intercept? It was 0, 8, right? 0, 8. How do I use this? Well, the c in our equation is equal to 8. So the very last piece of our equations, remember we have ax squared plus bx plus c, this thing. So c has to be equal to 8. Meaning when I write my equation, it's going to finish by me saying plus 8. Okay. So whatever this is, it's going to finish saying plus 8. Okay, we know the last piece. I also kind of know, looking at this graph, I know that I'm going to have a positive or negative in the beginning of it. What are we going to have? Yeah, this should have a negative something. I don't know what. It could be -1, -4, -12. I don't know, but it will be negative something in the beginning, right? Because, and how did you know that? Because, yes, it's opening down. Okay? So looking at the graph, we get the very beginning and the very end. Now we got to fill in the middle pieces. Okay? Step 2. We're going to use the roots on the graph, so our x-intercepts. We're going to put them back into factor form and FOIL them to get our equation back. Okay? So looking at this, what are the roots? We said it was x equals -4 and positive 2, right? To make them to go back to being a factor, you're going to add or subtract it back to the x. So this is x plus 4 and x minus 2. Okay. There's also going to be an a out front. Why is there an a? Because there might be a GCF. Okay. If a in the end ends up just being 1, then there wasn't a GCF, okay? But we don't know that ahead of time. So an a comes out, so a is a factor, x plus 4 is a factor, and x minus 2 is a factor. Do we understand how we got those 3 pieces? Okay, now we're going to put it all back together. So we're going to multiply back through, FOIL the factors. So a is still over here. So we have x times x, which is x squared. X times negative 2 is negative 2x. 4 times x is 4x, and 4 times negative 2 is negative 8. Bring these guys back together. Let's see, what does that give me? Plus 2x minus 8. And to completely squish them all together, I will have to distribute the a to each piece. So we're going to have a x squared, that looks familiar, plus 2ax minus negative 8a. So FOIL and distribute them all back together to get some kind of an equation. We are not done. We're not done. We are almost there. We're almost there. Looking at the graph, we already know the end and the beginning, okay? Looking at the x-intercepts, we make them factors again. We multiply them through to get an equation. Now, this is where we're going to find out if we have a GCF or not, okay? What does C have to equal? C has to equal 8. Right now, it says that C is what? Negative 8a. So in the beginning, we had C was equal to 8, right? That equation we just had, what was it? I'm trying to remember. There we go, 2ax. So, based on this, looking right here, if that has to equal 8, then a has to equal negative 1. So the very first step, we knew C had to be 8. After putting all my pieces together, the C was negative 8a. We used that piece by itself to solve for a. Now we know a is negative 1, and now we can plug it back in. This is our last step. So negative 1x squared plus 2 times negative 1x minus 8 times negative 1. This gives me negative x squared minus 2x and plus 8. And now we have our final equation. Does it have a negative to begin with, like we thought it would? Yep. Is it ending with a plus 8 like it's supposed to?
Yeah.
Yes. It is a lot. I know it is a lot. I know, mine too. This is my 3rd time doing this. My brain still hurts. We probably have time for one more. Okay, so we'll do one more. Since we won't get to the last problem of our notes, only do the first 2 graphs on your homework. Don't do, I mean, there's a whole 3 of them there, but just do the first 2. Don't do that last one. And don't, scratch through it. We'll do it tomorrow. You're just not going to do it tonight. Okay? So let's do one more like this to help you with homework. Yes? From foiling. When I foiled my factors back together. That's where it came from.
She went back to her slide.
She asked where the 2 came from. So I'm showing her it's when we foiled our factors together. That's where we got it from. All right, last one. We can get through this. We can do it. We have 7 minutes. All right, moving on. Here's our next problem. We have our graph. It is opening up or down. It is opening down. So what do we already know about my equation? It's going to have a negative in there. Awesome. And we already know how it's going to end. It's going to be negative. We don't know. But what's going to be on the very, very end? What is our y-intercept? 5. Our y-intercept right here, C has to be equal to 5. Because our y-intercept was 0, 5. Okay. Now we're going to use the x-intercepts, right, to make our factors, and we're going to FOIL them together. So where are we crossing right here? -6. So we have x equals -6. And this one right here? +1. So my factors, and there's always going to be an a out here, are going to be x. Yep. Is it 6?
I can't see that.
Yeah.
1, 2, 3, 4. Ooh, that's a 5. That's a 5. All right, let's FOIL them together. So we're going to have x squared minus x plus 5x, and then finish it with -5. We remember how to FOIL, right? We're distributing the x to those two, and then we distribute the 5 to both of them. Combine like terms in the middle. That's -1 plus 5, which gives me a +4, minus 5. One last step to squish them all back together is to distribute this a to all the pieces. So we have a x squared plus 4ax minus 5a. Does it? Plus 4ax. Okay, so yes, from the beginning, we know that C has to be 5. So this piece right here has to equal 5, which means A has to be -1 again. Let's plug it back in here. -1 x squared plus 4 times -1 x minus 5 times -1 will give us -x squared minus 4x and plus 5. We have the negative like we knew we would, and we have plus 5 at the end. Okay? I am asking you to do 2 problems tonight. Okay? 2 of them. The first one, I give you the equation. I want you to find the pieces and graph it. The second one, I'm giving you the graph. I want you to tell me the equation. Okay?